Once again, we're going to look at some problems incorporating the evaluating evaluating polynomial inequalities, okay, and based on the graph, okay. In this problem, what we're asking here is, okay, that based on this expression and based on the graph, y is equal to the negative x squared times x minus 1 quantity cubed and x minus 2. And this being the graph of that, okay? When is this expression greater than 0? If you know what it's asking, it's a simple expression, a simple problem, because all it's asking is when is this greater than 0? Which means when is the graph above the x-axis, which is clearly only in this region, which is the region between, I guess that's 1 and 2. It's clearly the region between 1 and 2, and that's all you have. If you were asked when is it below the x-axis, it's just as simple, okay? There's 1, 2, there's actually 1, 2, 3 regions, okay? Because if I was asking when is it below, I'd have to partition this as negative infinity to 0 and 0 to 1, because that's when it would be below, because if it were to ask that, okay? And it have to be written as 2 intervals, because the 0 would not be included. Had this asked when is it below, or when is it less than or equal to 0, then I could put that as 1 interval running from negative infinity to 1 bracketed. But that's not what we asked for anyway, but it's just something to bear in mind. Okay, the graph of two quadratic functions are shown. Okay, there's the one as shown, there's the other. Based on that, when is this expression, okay, which is nothing more than the numerator being this component and the denominator being this component, it's saying when is that less than 0? Saying when is their ratio less than 0? Well, for one thing, okay, the numerator component graphed by a quadratic expression up here is always positive. So what you're having is something that's always positive divided by something which is always negative, which is always going to be negative. So therefore, when is this expression going to be less than 0? Everywhere, everywhere, everywhere. If we were to ask the opposite question, like when would that expression, all that x squared, da 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 da, and negative 3 and everything, when would that be greater than 0? Well, again, the ratio of something that's always positive divided by something which is always negative is going to be negative, and if that were the question, then it would be an empty set, okay? So just some questions to think about based on what we've been looking at with these polynomial inequalities. And in actuality, this is what we call a rational inequality, because it's actually a polynomial divided by another polynomial. But we'll have more to say about that later.